Hello everyone, you're welcome to our class today. Today we are going to look at Introduction to Organic Chemistry. So we're going to know what organic chemistry is and what organic compounds are. So organic chemistry is the study of compounds containing hydrogen and carbon, and of compounds containing other elements in addition to carbon and hydrogen. So if you have compounds that contains hydrogen and carbon, the study of such compound is referred to as organic chemistry, such as this is an example of a compound that contains carbon and hydrogen. You can also have compounds that contains carbon, hydrogen, and other elements, such as this. So what we see here, it contains carbon, hydrogen, and oxygen. So compounds that contain this are referred to as organic compounds. So when we study these compounds, what we're studying? We're studying organic chemistry. Now, why is it that we have different carbon compounds? Two reasons are highlighted here. The first one is that carbon readily bonds to itself. It readily bonds to itself, and that is why they have different organic compounds. So they can bond to other elements, including metals. Another reason is that carbon can bond in a variety of ways, giving rise to chains, rings, and cages. As a result of these two reasons, that's why we have different carbon compounds. So when we look at organic compounds that contains carbon and hydrogen only, we refer to them as hydrocarbons. So carbon that contains carbon and hydrogen only, organic compounds that contains carbon and hydrogen only are referred to as hydrocarbons. Hydrocarbons are classified into two. The first one is aliphatic hydrocarbon and aromatic hydrocarbon. When we talk about aliphatic hydrocarbon, we refer to compounds such as alkanes, and alkynes. So these are compounds that are referred to as, so this is a group of organic compounds that are referred to as aliphatic. Then aromatic compounds contain one or more arene ring. More like a benzene ring that contains one or more benzene rings, right? Such compounds are referred to as aromatic compounds. Now, how do you represent organic compounds? There are different ways can be represented. So these are types of formulas or ways that they can be remembered or represented. The first one is molecular formula. Molecular formula shows the number of atoms present in a molecule of an organic compound. For example, we have this C6H14. So we have 6 carbon atoms, which is what I have there. 6 carbon atoms, which is this. So this. So when we count the carbon atoms, they are 1, 2, 3, 4, 5, 6. So 6, that's the C6. When you count the number of hydrogen atoms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So C6H14. And this is referred to as a molecular formula. We also have general formula, which is written for a series of compounds. For example, the alkanes have the general molecular formula, which you have there, CnH2n plus 2. And for the alkenes, the formula is CnH2n. So that is one. We also have structural formula. The structural formula shows how the atoms are joined together in a molecule. For example, ethane. So let's go back to the diagram I drew earlier. This one here is CH3, which is what we have here. The next one is CH2. Let's take the carbon atoms each. CH2, which is representing this. Then also the next one here, CH2, 1 carbon, 2 hydrogen atom, which is this. And this is also CH2, which is representing this. Then this is CH2, which is representing this. And this is CH3, 1 carbon atom, 3 hydrogen atom bonded together. That is this. This is called structural formula. The next is displaced formula, which I drew earlier. So this is how the displaced formula for hexane is. Then lastly, we also have skeletal formula. Now, when we see skeletal formula, it shows all the bonds and all the atoms for the organic compound. So we have this ends here, this one here, this here, this here, this, and this. They represent carbon atoms. It's more like saying I have a carbon atom here, there's a carbon here, there's a carbon here, another one here, another one here, another one here. That is 1, 2, 3, 4, 5, and 6. So 6 carbon atoms. So this is hexane. Then lastly, it can also be presented in 3-dimensional formula, which shows how the atoms are bonded. So it best represents how the atoms are bonded. Let's look at the model here. This is for methane. This is how methane is. So when I look at the methane structure, it shows how the atoms are bonded. So when we look at it, so this is the methane, the model of the methane structure. So this one, the one here, so this is carbon atom, and the white ones are the hydrogen atoms. So here it shows how the carbon atom is bonded to the 4 different hydrogen atoms. When I rotate this, you see how the atoms are bonded, how the hydrogen atoms are bonded to the carbon atoms. You can also get the bond angle. So look at the bond angle. The bond angle is about 109.5 degrees. When you come down, you also see the structure, the shape of the molecule, which is what? Tetrahedral for methane. Generally, the alkane, you have a tetrahedral shape, and that's what is peculiar or common to the alkanes. So far, we are seeing what organic chemistries are. Organic chemistry has to do with study of carbon and hydrogen, and also compounds that contain carbon, hydrogen, and any other elements which could be a non-metal or a metal. And we've seen why organic compounds contain different carbon atoms. Why we have many different carbon atoms, I've seen it as well. And we've also seen that hydrocarbons here are compounds that contain carbon and hydrogen. An example of the carbon is family of the carbon or homologous series that belongs to it, and the carbon are the alkanes, and alkynes. We're also seeing how formulas can be used to represent the organic compounds. We have them here: the molecular formula, the general formula, structural formula, displaced formula, and skeletal formula. So thanks for watching. I'll see you some other time.